In this video, we're going to talk about coterminal angles. We're also going to go ahead and talk about reference angles now as well, because it is so common for people to mistake the two or intermingle the two. Coterminal angles are actually really basic. Coterminal angles specifically talk about where two angles terminate at the same location. So for instance, if I were to draw an angle in the coordinate plane and say that there's my standard position starting, and I go to this location right here. So this angle, say, might be 120 degrees. And I'm going to go ahead and write that. This is theta equals to 120 degrees. This is theta. This angle right here is coterminal with the angle that starts in the same standard position and ends in the same location, but isn't the same angle. So for instance, if I go backwards from here to here, now that angle measure, which I'm going to call phi or phi, is actually going to be equal to a negative 240 degrees, specifically referencing the fact that this angle here is ending and starting in the exact same spot. That's a coterminal angle, where two angles start in the same position and end in the same position. So for instance, I could draw another coterminal angle to this that's not those two angles. Keep in mind that whenever we're referring to angles, there is a point where we can actually double up the rotations. So I can go ahead and start at the standard position, I can rotate one full rotation, and stop in the same location as I did before. This right here is still considered coterminal to these two other angles. I'm going to call this one alpha this time. And this time alpha is actually going to be, well, 360 plus the 120 is 480 degrees. So sure enough, these three angles, all three angles that I've drawn, are all coterminal to each other. Those specific angles, again, can be in reference to basically looking at adding 360 degrees or subtracting 360 degrees. Keep in mind, this can be done also with radian measure. So for instance, theta equals to 120 degrees, I can utilize that d over 180 degrees equals to r over pi. I can use this to transform these angles into different values. In my head, I'm going to go ahead and do it slightly differently. I know that 120 degrees is the same as two full measures of 60 degrees, and I remember from the previous videos that 60 degrees is pi over 3. So this angle right here is the same thing as my radian measure theta of 2 times pi over 3. It's two of those pi over 3 measures. We can go ahead and repeat this process with all the other ones. For instance, this is 4 of those pi over 3s. So I'm going to have a negative 4 pi over 3 is my theta measure here. Now, if I were working with just the radian measures and I didn't have these degrees in front of me, sure, we could convert the radians 2 degrees using this formula and get the 120 and then do the 360 minus. But if I'm not working with that, what I can do is, just like I did here, I technically subtracted 360 degrees from 120 to get negative 240. I can subtract 2 pi from 2 pi over 3. Again, when doing so, if I do that down here, if I do 2 pi over 3 minus 2 pi, I'm going to go ahead and find myself a common denominator, changing this to be 6 pi over 3. And there, sure enough, I'm going to get the same thing as a negative 4 pi over 3, which is the value that I have right here. So again, anytime we're working with coterminal angles, the goal is to either add 360, again, notice 120 plus 360, add 2 pi. If I added 2 pi to this, it'd be like adding 6 pi over 3 to 2 pi over 3, which means that this is the same angle as going to be, if I can do math right, 8 pi over 3. Or I can subtract 360, which is what I did here, or subtract 2 pi, which is what I did here. So again, that's the concept of a coterminal angle. It's terminating in the same location as the angle that's been given. Now let's talk about reference angles, because reference angles are actually the more important ones, but they're a little bit more complicated to understand. So coterminal terminates in the same spot. Reference angles, however, focus on in the quadrant. So we can't really necessarily do this without drawing the reference angle in the quadrant. Let me start with some basic drawing of angles. Let's say theta is equal to a negative pi over 4. Now I'm doing this negative pi over 4 because I want us to start talking about radian measures and how they sit. Well, pi over 4 is the same thing as 45 degrees. In this quadrants here, I have 0 degrees, I have 90 degrees, I have 180 degrees, I have 270 degrees, and I have then 360 degrees. And yes, I'm going to write both of those there because it is both 0 and 360. So where is negative 45 degrees? Because pi over 4 is 45 degrees if I convert it correctly, and I get negative pi over 4, negative 45 would be coming halfway down here, because 45 would actually sit in this quadrant, but because I'm going negative, I originally start here, I come down 45 degrees, and that sits right there. So that right there is theta, okay? So the question is what is the reference angle? Now maybe negative pi over 4 was a bad one to start with, but it is one that still works. The reference angle is the angle that you get. It's positive. It's between 0 and 90. So the reference angle must be 0 to 90. Okay? It must be between 0 and 90, meaning it must be between 0 and pi over 2. And it has to be positive, okay? Which means that I have to come up with an angle that's a reference. It's a reference for this one. What is the reference angle for this one? Well, what does this angle better or most appropriately represent? Well, it represents an angle if I were to create a triangle cutting back to the x-axis, always back to the x-axis. What is that angle there if this were a triangle? Well, it's never going to be negative 45. It'll actually be a positive 45. Again, somewhere between 0 and 90. So in this case, my theta's reference angle, and again, the way that we use the reference angles is that we're going to go theta prime. So this is the notation for a reference angle. If this is theta, what's theta prime? What's the reference angle? Well, the reference angle is pi over 4. Now this one might have been too simple to create because of the fact that if I go negative direction, that's what it's going to be. Well, let me go ahead and create a different angle that has the same location. It has the coterminal position of this particular angle. That angle is going to be, let's see here, 1, 2, 3, 4, 5, 6, 7 pi over 4. And what I just did, I will show you in another video of how I create the unit circle. But 7 pi over 4 is the the coterminal angle to this. What's the reference angle? What is theta prime going to be? Well, keep in mind that if I go this way or the other way, it doesn't really matter. I still need to go ahead and create a triangle cutting back to the x-axis. And the angle that's left over right in here will be my theta prime. Again, if this is theta, then cutting it back to the x-axis, creating that new angle right there, that's my theta prime. So in this case, it's still pi over 4. Let's go ahead and do this for all 4 quadrants. Now this right here was in the 4th quadrant. Notice how in the 4th quadrant I simply just cut it back to the x-axis going up. Now if I create another angle, let's go ahead and do let's do phi equals, and we're going to go ahead and make it 30 degrees, something simple. So phi equals 30 degrees is created by this right here, give or take. Okay, that's 30 degrees. That's phi. The question is what is the reference angle? Well, the unimportant part about the first quadrant is that every angle you create is more or less going to be its own reference angle, assuming you cut back to the x-axis. So if I cut back to the x-axis, what does that angle create? Well, phi prime is going to be 30 degrees. It's important for us to recognize again that coterminal angles create the same reference angle. So if I instead made this rotate all the way around one full time and then hit that point, that's actually going to be, I'm going to call that, I'm not going to call it anything special. I'm just going to say that I know that that's 390 degrees. 390 degrees is still going to create that drawing. I'm still going to cut it back to the x-axis, and you'll notice that I'm going to have to remove 360 degrees to find out what that reference angle is of 30 degrees, or pi over 6 if I'm using radians. So the first quadrant is really kind of universally simple unless you've got, again, these rotational situations where we go backwards or forwards. The fourth quadrant is also relatively straightforward, especially if you're going forwards or backwards. Let's talk about the second and the third quadrant. In the second and the third quadrant, fun things happen. Okay, so let's talk about the second quadrant. Let's do something, let's do 2 pi over 3 like we had before. So I have, let's do alpha equals 2 pi over 3. It's the same thing as 120 degrees, just to make sure that we note that. The importance of this one is the fact that this particular angle lands like this. So that's my actual alpha. What's the reference angle? Well, remember, in all these examples, I cut the angle that I created back to the x-axis. Back to the x-axis. So it's going to cut back to the x-axis. And this is the first example where the reference angle isn't really easily relatable to that of your original angle. So right in here is your alpha prime. So what is alpha prime going to actually be equal to? Well, if we're doing it in degree measures, well, it's just what extra additional angle measurement do I have to get to go from 120 degrees to this 180 degrees, this measurement back to here. In that case, it's going to be 60 degrees. More appropriately, it's just going to be pi over 3, because what's going to take me to get to pi over 3. So again, reference angles are focusing on what it takes to get to the x-axis, be it cutting back in the negative direction or cutting it forward into the positive direction. No matter what you do, whether you cut it backwards or forwards, in any case, it's always going to be a positive angle measure that we're going to look for. Pi over 4, 30 degrees, 60 degrees. Let's go ahead and talk about one last one, again, in the third quadrant. This is the last case that we have to work with. And let's do a negative angle. Let's go ahead and say we have beta equals to, let's do a, not 120, let's do a negative 150. So in this case, we're going to go ahead and go all the way back this way to about there. That's the beta measure, which means that if I'm going to try and create my reference angle is going to be here. This is beta prime. Okay, again, I create my triangle cutting back to the x-axis. There's my beta prime. I need to figure out what is beta prime going to be equal to. What is the angle measure right here based on that particular triangle? Well, if this is negative 150 degrees, then this measurement here to get us back to that x-axis, this is a total of 180 degrees. Yes, I'm kind of intermingling the concept of positive and negative here. So this is 150 plus 30 more gets me to this 180. So I need a positive 30 degrees. Keeping in mind, again, that my reference angle will always be a positive angle, never a negative angle. So coterminal angles can be positive or negative. All they have to do is end at the same location. The difference between the coterminal and the reference angles is that all of my reference angles have to be positive numbers and will always be creating triangles cutting back to that x-axis. Always creating those right triangles cutting back to the x-axis, where we then ask ourselves, what is the angle measurement in that triangle? In some cases, generally the first and the fourth quadrant, those angles are easily created by the triangle or by the angle that we're already creating. Those triangles are easily built. In cases of other ones or larger angles, things get a little more complicated where we have to do some addition and subtraction. Depending on what we're working with, will arguably change what we're adding and subtracting. It's more of a logical basis in this case because I'm working with a negative 150. I have to add additional values to get to that 180. In this case over here, I have to add additional values to get to that 180. But in some cases, I might have to subtract back to the x-axis to get that 180. So it's a matter of how you work with these, but just make sure that you understand what the difference is between reference angles and coterminal angles. We will be working with reference angles viciously more later in other videos.